So we're moving on through the same question, and this time we're asked about the third particle. So we're told that the third particle is an electron antineutrino, and we're asked to explain why. Why is it an electron antineutrino rather than an electron neutrino produced during the beta decay? So for the first marking point, what we're really looking for is this clear statement that in beta decay, the electron produced is a lepton. So in beta decay, the electron produced is a lepton, and then antileptons have a lepton number of -1, and then we need to state that lepton number must be conserved. So this statement, lepton number must be conserved, is required for one of the two marks. And then either of these two statements is good enough for the second, but you must have a statement about lepton number being conserved to score both marks in this one. The next part we move on to is this Feynman diagram. So it's a Feynman diagram of a decay, and we're asked, and we're given that a large tank of water is used as part of the electron neutrino detector. So figure 2 represents the interaction. So we've got the interaction between an anti-electron neutrino. We've got the mediating particle, and we've got a proton coming in, and we've got a Y, some particle we're going to have to identify, and we've got X, and then we've got a anti-electron. Positively charged electron is the anti-electron. Okay, and then we're asked to identify X and Y. Within this, okay, these are quite straightforward. At each vertex, so each junction, all the normal conservation rules apply. So we can ignore all the rest of this. We can ignore the right-hand side for now. And an anti-electron neutrino goes in, and we get an anti-lepton. So we've got an anti-lepton, a neutral anti-lepton, becoming a positive charge, a singly positive charge anti-lepton. So lepton number's fine here. This doesn't have a lepton number, doesn't need to have a lepton number, but charge isn't conserved. We're going from 0 charge to a +1 charge, and the only way that we can have that conserved is that this thing must have a charge of -1. It's it'll be a boson, and it's a negatively charged boson, so a force mediating or a fundamental interaction mediating particle with a negative charge. There's only one of them that exists, and that's the W- boson. So X is a W- boson. And then we've got a proton, and again, we can now ignore the left-hand side. The proton is interacting with the W- boson to give me something, this Y. Now, proton has a baryon number 1. The W- boson doesn't have a baryon number, so this must be a baryon. The charge is +1, the charge is -1. So +1, -1, it must be neutral, because overall this and this are neutral. So it's got to be a neutral baryon. Well, a neutral baryon coming from a proton is going to be a neutron. So it will be a neutron that's produced. So Y is a neutron.